Hey ladies and gentlemen, this is Ms. Humbert here, and today we're going to be doing Unit 7 Learning Target 15. So we're going to be talking about mutually inclusive probabilities. So yesterday we talked about exclusive, today we're going to talk about inclusive. So inclusive events are events that do affect each other. So for example, if I'm reaching into a deck of cards, if I take one out, that's going to affect it. Okay, so for example, if I roll a dice and the number is less than 5 or a 1, guess what? Less than 5 and a 1 could be the same thing. And that's what makes them mutually inclusive events, because we have probabilities that could end up being the same thing. So let's take a look. Mutually exclusive versus inclusive. So mutually exclusive, an item that can't be both. That's what we worked on the previous note sheet. Inclusive is when an item can be both. So today we're going to be working on when things could be more than one thing, meaning they do affect each other. So let's take a look at an example. So, oh my, that's beautiful. Some art. Okay, so we want to find the probability of each event. So suppose that 1,400 students, of 1,400 students, 550 take Spanish, 700 take biology, and 400 take both. And we want to find the probability of selecting Spanish or biology. Well, when we count Spanish, that could be counting some students that are also taking biology. And while I would like to think students are very important, I don't think they're very important to be counted twice. So that's why we have to subdue that. So what I'm going to do is I'm going to start, and I'm just going to first calculate out the probability of just Spanish. So I'm going to calculate the probability of just Spanish. So I have 550 out of 1,400 students that are just taking Spanish, or just the Spanish part. Then I'm going to take the probability that they're doing biology. So I'm going to take, and I'm just going to focus on the biology number they gave me. Then, once I've gotten the before and after on the previous note sheet, that's when we stopped. But what we're adding today is now we have to subtract the probability that it's both. So now what I'm going to do is I'm going to subtract the probability that it's both. So there's 400 taking both. So I'm going to subtract off the probability that it is both. So then when we do that, remember when you add fractions, you're going to keep your denominator the same, and then you're going to add, subtract. So you're going to take 550 plus 700 minus 400, and that's going to give you 850. Now, once you've gotten to this point, you're going to divide that out. 850 divided by 14,000 is going to give you 0.61. So there's a 61% chance that they're taking Spanish or biology. They could be taking one or the other. Let's take a look at number 2. So number 2 says there are 2,400 subscribers to an internet server, okay? So 1,200 of them own HP, 500 own Dell, and 100 own both. What is the probability that they own HP or a Dell? So to start off with, I'm going to calculate the probability of HP. Well, I see there's 1,200 out of the 2,400 that own an HP. Then I'm going to take and I'm going to add the probability that they own a Dell. So a Dell is 500 out of the 2,400. So now I've taken care of those two. But now I need to subtract off the probability that it is both, which is 100. So now I'm subtracting off 100. Then what I'm going to do is I'm going to add this and subtract this. So 1,200 plus 500 minus 100, that's going to give us 1,600 divided by 2,400. And when you divide that out, you get 0.67. So that means there's a 67% chance that they own a Dell or an HP. Let's take a look at number 3. In the game of bingo, balls are numbered 1 through 75. These numbered balls correspond to columns on a bingo card as shown in the table. A number is selected at random. What is the probability that it is a multiple of 4 or is in the O column? So let's go ahead and let's take a look at that. First of all, what I want to do is I want to write out all of my multiples of 4 from 1 to 75. So I'm going to go ahead and do that. I have 4, I have 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, and that is it. So let's count how many multiples of 4 we have, because that's the first probability, that it is a multiple of 4. So let's count that out. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 out of the 75 numbers that are multiples of 4. The next thing I want to figure out is the probability that it is in the O column, which is right here. So we have 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75. So what I did when I read out all of those numbers is I counted them out on my hand. And when I counted them out on my hand, I got 15 out of 75 that were in the O column. So what I need to do next is figure out how many numbers are in the O column that are also degrees of, or multiples of 4. So what I'm going to do now is I'm going to see, okay, so it starts at 61. So after 61, I have 64, 68, and 72. So those three numbers are multiples of 4, and they're also in the O column. So right now, they're being counted twice. So that means I need to subtract them off. Since there's three numbers, I'm subtracting off 3 out of 75. So let's go ahead and now we can simplify our fractions. So we're going to do 18 plus 15, and then we're going to subtract 3. 18 plus 15 minus 3 is going to give us 30 out of 75. So then you're going to take 30 divided by 75, and that gives you 0.4. Okay, so that's going to give you 0.4. Next, let's take a look at number 4. So for number 4, what we want to do is calculate out that probability. So we want to find the probability that a card is drawn from a standard deck of cards. What is the probability of drawing an ace or a red card? So what we're going to do is we're going to calculate each of the probabilities before and after the or first. So what's the probability of it being an ace? Well, there's 4 aces in a deck, and there's 52 cards. So there's 4 out of 52 that are an ace. Then we want to find the probability that it is a red card. Well, a red card is half of the deck, so that's 26 out of the 52. So plus 26 out of 52. Then what we want to do is we want to subtract off how many are going to be duplicates. So I want to figure out, okay, in a deck of cards, how many are ace and how many are red? Well, if we think about it, there's the ace of diamonds and the ace of hearts. So 2 of my 4 aces are going to be red, which makes sense because half of my aces should be red. So I need to subtract off that 2 out of 52. Then we're going to add across 4 plus 26 minus 2. So that's going to give us 28. And again, you're going to keep your denominator the same at 52. Okay, so then what you end up getting is 0.54. So there's a 54% chance that you have, you're going to get an ace or a red card. So let's take a look at number 5. There are 100 students that participate in spring sports. Okay, 15% participate in track, 14 participate in softball, and 2 that participate in both. So first we want to figure out there's 100 students total, okay? So how many of them participate in track? Let's start there. Well, it gives us that there's 15 in track. So 15 out of the 100 participate in track. Then I want to figure out how many are in softball. So I'm just focusing on softball. So out of the 100, 14 are participating in softball. So now I have track and now I have softball. And now what I need to do is I need to subtract the probability of it being both. So I'm going to subtract out the probability of it being both. Well, it gives us that there are 2 that are participating in both. So I'm going to be subtracting off 2. So I'm going to do 15 plus 14 and then minus 2. And that's going to give me 27 divided by 100. And that gives me 0.27. So there's a 27% chance that if we pick someone that they are in track or softball. Let's take a look at this last problem here. What is the probability of drawing a 10 or a club from a standard deck of cards? So let's take a look. First of all, let's find the probability of getting a 10. So let's think about a standard deck of cards, right? So for a 10, there's going to be 4 10s in a deck. So 4 out of the 52 are going to be 10s. A club, well, a club is one of our suits, and there's 13 of each suit. So then we're going to do 13 out of 52. Now, we need to subtract off the probability that a card could be a club and a 10. Well, there's only going to be one 10 of clubs, so that's we're just subtracting off 1 because there's only one that doubles up. So we have 4 plus 13 minus 1, and that's going to give us 16, divided by 52, and that's going to be equal to 0.31. So there's a 31% chance that it is going to be a 10 or a club. Next, let's go ahead and let's take a look at all of these. And we want to figure out if it's going to be mutually exclusive or inclusive. So if we're drawing a heart or a diamond from a stack of cards, so to figure out which one it's going to be, you need to ask yourself, is it a possibility that it could be both? So you need to ask yourself, could it be a heart and a diamond? Well, a heart is a suit and a diamond is a suit. So a card can't be a heart and a diamond. So that makes this mutually exclusive. Taking a look at number 2, drawing an ace or a spade from a deck of cards. So we want to ask ourselves, could something be an ace and a spade? Well, an ace is a type of card and a spade is a suit. So yes, it could be both because we have the ace of spades. So that makes it an inclusive event because it could be both of them. Next, let's take a look at this one, rolling a 5 or rolling a number greater than 3. So again, we need to ask ourselves, could it be larger? Okay, could it be a 5 and could it be greater than 3? Could it be both? Yes, it could be both, so that's going to make it inclusive. Next, let's take a look at this one. Picking a red or blue M&M out of a bag. Could you have an M&M that is both red and blue? No, you can't, unless there's a serious factory malfunction, which we're not going to focus on. So that makes it mutually exclusive because it can't be both. Okay, so that concludes your note video today. Go ahead and show me your completed note sheet when you're done. Thanks for listening.